MAP4C 7.2, the present value of an annuity. The present value of an annuity is the principal that must be invested today to provide the regular payments of an annuity. So this is like a retirement fund. People deposit a certain amount of money into a fund which they will be making regular withdrawals from, called a pension, for a set period of time. So this is our formula. Present value is equal to the regular payment that you expect to receive in the future, the interest rate adjusted for the compounding interval, and n is the number of times that you expect to receive the payment, which is also the number of compounding periods, because those payments and the compounding happen at the same interval in an ordinary simple annuity. So your present value is equal to Rn minus I, where Rn represents the regular payment that you're withdrawing times the number of withdrawals that you make, so the total amount that is withdrawn. And I, as a capital, represents the total interest that has been accumulated. So let's talk about what this formula is applied to. The present value formula can only be used when the payment interval is the same as the compounding period, a payment is made at the end of each compounding period, the first payment is made at the end of the first compounding period. So this will be easier to explain when I take you through and trace a spreadsheet showing the amount that is invested. But let's look at a problem. Example: Victor wants to withdraw $700 at the end of each month for 8 months, starting 1 month from now. His bank account earns 5.4% per year compounded monthly. So we know that this is a present value problem because it says how much must Victor deposit in his bank account today to pay for these withdrawals. These are withdrawals in the future with a deposit that we're making now. So using the guess method, the given information, the unknown value is the present value, the equation that we need is the present value formula. We're going to substitute in our values, and then we're going to solve. So we solve this right here. Now, notice that the regular withdrawal we want is $700. The interest earned is adjusted from the annual percentage rate to a monthly rate by dividing by 12. And the number of compounding periods, or number of withdrawals, is 8 because it's monthly withdrawals for 8 months. So when we substitute into this formula, we get the following equation. In order to be able to evaluate this right-hand side, I like to use the brackets first. So 1 minus bracket 1 plus 0.0045 end bracket to the exponent -8. Then I hit equals. I multiply that value times 700, hit equals, divide by the interest 0.0045, and then hit equals. This says that the present value is $5,488.28. So what this means is that if I invest this today, I will get R times N, which is 700 times 8, $5,600 by the end of the investment. So that's the incentive to want to invest money now, because you will earn interest. Because if you are just getting $700 each month of your own money, then there has to be some incentive for you to want to do this. There will be interest that accumulates with the amount that is invested into the bank. So how much interest will Victor earn on the investment? The present value is equal to the sum of your regular payments. So R, the regular payment, times N, the number of times that you make that, withdraw that payment, minus the interest that's accumulated, because that's just what it is now. If we rearrange this formula for I, or isolate I in this equation, we end up with Rn minus PV. So Rn being your regular deposit, regular withdrawal times the number of times that you withdraw it. 700 times 8 is 5,600 minus the present value, what it is today, 5,488.28. So the difference between these two represents the interest. So the advantage of having all of the money deposited and only taking it out as needed is that you can earn interest on that deposited amount. A way of understanding this right here, we take the present value, this is what it is worth today. By having that amount invested at the beginning of month 1, we will earn interest, and I've used the interest value of 0.0045 multiplied by the starting balance to get the interest that is earned. Then I will withdraw $700 at the end of this first month, and the ending balance will be $4,812.98. So that is adding interest to our starting balance and subtracting our regular withdrawal. And our starting balance is the same as the ending balance from the previous period. The interest is calculated based on the amount that is still in the account. That is how it is earning interest, is because you are taking your money and allowing the bank to use it for a certain period of time, and they will give you a return on your investment, and it's this interest. Then you withdraw $700 at the end of this month and continue. If we look at the end of this, we have $700 withdrawn for 8 months, and the ending balance is equal to 0 because this represents the amount that is in an account. So by the end of this, we will have withdrawn all of the money, and we will be up in interest. What we could do is add all of these interest values. Let's just head over to Microsoft Excel to do that quickly. Equals the sum of these values. That's $111.72. So if we look, we match the value as calculated by our formula, and that's the process of what a present value problem looks like. Money is invested today, regular withdrawals are happening, and we're earning interest based on the amount that is still within the account. So I hope that helps you get started with these 4 questions. If you have any issues, please message me. Good luck.